Hello students, welcome to today's session. So today we will do Thermochemistry question part 6. So in this question session we will do practice question from 38 to 45. That will comprise total of 8 questions. So for each question you will be given 10 seconds to solve them. So I will also read the question slowly so that you get more and more time to solve your question. And at last I will also give the solution, right, and the correct answer. So first, if you have solved the question, very good enough. Just match your answer with the given answer. If not, then I will provide you with the actual solution. Then you can check your approach in that case, right? So with this, let us start our today's session. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of the original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the images. So moving on to the questions. The first question is question number 38, which says that the dissolution of CaCl2.6H2O in large volume of water is endothermic to the extent of 3.5 kilocalorie per mole. For the reaction, CaCl2 solid, that is calcium chloride, reacting with H2O liquid, 6 moles of H2O liquid gives us CaCl2.6H2O as the product. The delta H for this reaction is -232 kilocalorie. Hence, heat of solution of CaCl2 in a large volume of water is. Your options are A 26.7 kilocalorie, B minus 26.7 kilocalorie, C 19.7 kilocalorie, and D minus 19.7 kilocalorie. So what will be the hint for this question? So basically, you are asked the heat of solution, right? You have asked the heat of solution of say CaCl2. Okay, and in that you are also given the dissolution thing. So you must know that dissolution occurs in 2 steps. What are those 2 steps? That is upon you to determine. So with this, I think this much is enough to begin with this question. So your time starts now. Okay, your time is up. Let us see what is the solution. So first of all, let us try to understand the question. The question is saying that when you are dissolution means we are dissolving the CaCl2.6H2O in large volume of water to the extent of 3.5 kilocalorie per mole. Okay, so when this is dissoluted in water, this much amount of energy is released. Next, for this reaction, for this compound to form, this much energy is required. So you have to find the heat of solution of CaCl2. Okay, so for those who have solved, the correct answer is D. Now, this reaction is already given, and the heat of say the water addition is also mentioned, which is minus 23.2 kilocalorie. Next thing which we have to do is we have to dissolve this solid thing into your aqueous parts. Right, so I have said you, so this will occur in 2 steps. So this is the first step, and this is the second step. Right. So next, what we have to do, we have to dissolve this thing directly into water to form this. So what is being said here is that if you want to form this compound, okay, if you have to form this compound, then you have to first add the water molecule, that is 6 moles of water molecule, and then you have to dissolve this into the aqueous solution. So when you add, it will be still be solid, only water molecules will be added, and then you dissolve it in large amount of water to completely dissolve this thing, right? So these two values are already given, and you have to find the overall value. So you will simply use the Hess's law, that either you can move from one step to the second step, or you can directly move from CaCl2 solid to the last one. Okay, both will have the same enthalpy of reaction. So keeping that in mind, we have performed the simple arithmetic calculation. So minus 23.2 kilocalorie plus 3.5 plus 3.5 kilocalorie. That will give you minus 19.7 kilocalorie as a correct answer. Okay. So with this question number 38 is done. Okay. So your answer, so your answer clue for this question, I would say, would be that you must remember that during this solution of CaCl2, okay, during this say solution, making a solution of CaCl2 in aqueous, you have to first add the 6 molecules of water, and then you have to dissolve the formed compound into form the aqueous solution. Clear? Once you are aware about these two steps, you can easily solve this question. Yeah, third thing that is very important here, Hess's law also. Right? Now moving on to the next question. Question number 39. The temperature of a bomb calorimeter rises by 1.6 Kelvin when a current of 3.2 ampere is passed for 27 seconds from a 12-volt source. Which of the following statement is true? Your options are A. The calorimeter is 648 joule per Kelvin. B. This calorimeter constant will be same if the calorimeter is open. And C. The information is insufficient for calculating calorimeter constant. And D. The calorimeter constant is independent of calorimeter content. So what is the hint for this question? So basically, what are the things that are given? So you are given that your temperature of the bomb of calorimeter is rising by 1.6 Kelvin when you are applying a current of 3.2 ampere for 27 seconds, right? For it from a 12 volt. So which statement is true? So you have to basically see the statement which is true, and in this case, I would say that you should be able to calculate the overall work. Current and all are given, right? So your 10 seconds to solve this question starts now. So your time is up. Let us move to the solution part. I've already explained the question to you. For those that solved, the correct answer is A. So this is the thing. Q is equals to IT, and that will give you the total work or the energy produced, right? So I've told you to calculate this thing. So this thing is first calculated. So for that we have calculated Q, because what is current? It is charge passing per unit time. So charge is equals to current into time. Now charge multiplied by the voltage gives us the total work done or the total energy produced. That is 1036.8 joule. Therefore your calorimeter constant will be what? It will be 1036.8 by 1.6, that is 648 joule per Kelvin. Clear? Simple? Okay, moving on to the next question. Question number 40. Question number 40 says that for the complete combustion of ethanol, C2H5OH liquid plus C3O2 gives us 2CO2 plus 3H2O liquid. The amount of heat produced as measured in bomb calorimeter is 1364.7 kilojoule per mole at 25 degrees Celsius. Assuming the ideality, the enthalpy of combustion for the reaction will be, your options are A. Minus 1366.95 kilojoule per mole. B. Minus 1361.95 kilojoule per mole. C. Minus 1460.50 kilojoule per mole. D. Minus 1350.50 kilojoule per mole. So you are given a combustion reaction, and for the amount of heat produced is measured in the bomb calorimeter is also given, right? And you have to calculate what? You have to calculate the enthalpy of combustion. So the hint for this question will be what? So you are what you are given is that you are given the equation, right? You are given the equation, and the heat produced is also given, and all these things are happening at constant volume, okay? Because this is a bomb calorimeter. Now I think this much thing is this much hint is more than enough to solve this question. So let us start the timer. So your time starts now. Okay, so your time is up. Let us move to the solution. Let us see how can we solve it. So the question was saying that you are burning the ethanol, and during that combustion the heat that is produced is 1364.47 kilojoule per mole. Now for the same reaction you have to calculate the delta H combustion, right? As well as your R was also given, which is 8.314 joule per Kelvin per mole. So the, as I said, the for those who solved, the correct answer is A. So what will be the solution? So this is our equation, right? So I have already mentioned that all of these are happening at constant volume in case of warm calorimeter. Therefore, the heat produced can be written as QV, and we know that at constant volume the heat produced is equals to the internal energy change. Therefore, I have written the same value as your delta U. Now there is a negative sign against it. So this thing is given because the heat is being produced, right? So it is being released by the system. So therefore, it is lost by a system when we represent it by negative. This is very obvious. Next, we'll use this equation, which is delta H is equals to delta U plus delta NGRT. How can we calculate this delta NGRT? So this is delta NGRT is already known. They both are constant as your reaction is occurring at 25 degrees Celsius. That is your constant temperature. You need to calculate the change in gaseous number of moles. Okay. So here on the right hand side we have only 2 moles of gases, while on the left hand side we have 3 moles of gases. So that will give you delta Ng is minus 1. Okay, 2 minus 3 minus 1. Putting all these values here, so this thing is given already. I have put it here. Minus 1, 8.314298 by 1000. So why are we dividing it by 1000? Because this thing, which is delta U, is already given in kilojoule per mole. So to add this whole term and this whole term, we need to keep their unit same, and also we need the value of delta H in kilojoule per mole. So for that reason we have divided the R with whole term, this term, by 1000 to keep the unit of, say, delta Ng RT as kilojoule. Clear? So in this way you will solve this one. Now if you perform the calculation, that will give you minus 1366.95 kilojoule per mole as the correct answer. Moving on to the next question. Question number 41. The enthalpy of dissolution of BaCl2 and BaCl.2H2O are minus 20.6 kilojoule per mole and minus 6.8 kilojoule and 6.8 kilojoule per mole. The enthalpy of hydration for this reaction is what? Okay, so your options are A 29.4 kilojoule, B minus 29.4 kilojoule, C minus 11.8 kilojoule, and D 38.2 kilojoule is your last option. Now how we'll solve it? So the hint for this question is that to this process to occur, 2 steps can be individually written such that you can involve this value and this value. Then you can simply use the Hess's law to find the answer. So I think this much hint is more than enough to solve this question. Your time starts now. So your time is up. So let us see the question first of all. So the question is saying the dissolution of BaCl2. So when you dissolve BaCl2 in water, then what is the dissolution? Okay, and when you dissolve this thing, which is already having the water of crystallization, when you dissolve this thing, then what is the water of dissolution? Okay, those two values are given. So for those are solved, the correct answer is B. So I was saying this thing, right? If you dissolve this BaCl2 plus 2H2O into water, you will get dot 2H2O. Okay, so first we are adding water of crystallization, which is the first statement, minus 20.6 kilojoule. For the second statement, we are dissolving this BaCl2 having water of crystallization into water, and in that case your delta H is already given, which is plus 8.8 kilojoule. Okay, Now overall reaction will be addition of these two, which is this reaction. So we'll add these two reactions. So 1 minus 2. So first we will reverse this, then we will add this. Okay, we will reverse this equation. Right? We will reverse this equation because at last we did this thing. Okay, so if we just add both of this, we will get this thing also on the left hand side, and we need this thing on the RHS, whereas the aqueous form on the LHS, so that it can be cancelled out with the upper one. Okay, so for this we will first reverse the equation 2, so that will create a negative sign, and then we will add this both. So delta H is equal to delta H1 minus delta H2, and hence putting these values will give you minus 29.4 kilojoule as your correct answer. Clear? Okay. Now moving on to the next question. Question number 42. Question number 42 says that the standard enthalpy of formation at 298 Kelvin for CH4 methane in gaseous state is minus 74.8 kilojoule per mole. The additional information required to determine the average energy of CH bond formation are. Your options are A, the dissociation of energy of H2 and enthalpy of sublimation of carbon. Option B, latent heat of vaporization of methane. Option C, the first for ionization energy of carbon and electron gain enthalpy of hydrogen. Option D, the dissociation energy of hydrogen molecule. So how will solve it? So what we have, so I will give you the hint basically. So when you will write the standard thermochemical equation for the formation of CH from CH4 from its elements in the standard state, then in that case you can write the enthalpy in terms of the dissociation energy of bonds, right? So you will use that equation or use that concept. Now your 10 seconds to solve this question starts now. The time is up. Let us move to the solution part. The question was saying that if you form 1 mole of methane from its constituent element in the standard state, then you will get 74.8 kilojoule per mole of energy. Now the addition of information required to determine the average energy of CH bond. So you have to now determine the average of energy of CH bond. For that you must know that your delta, your sigma reaction, so sorry, delta RH for the reaction can be written as bond dissociation energy of reactant minus bond dissociation of product. So I have explained it earlier. Why is it so? So you must remember this thing. Now for those who have solved, the correct answer is A. So in this case, carbon is found in solid state, so you need the heat of, say, sublimation also. Sorry, the state of substance affect the surface. For the equation can be written as this one, and you need the sublimation also. I have told you. So let us see further. And for H to H2, your dissociation are also required. So what are the things that are being required? So first sublimation, and second your H2 gas is converting to 2H gases. Once you have all this, you can easily solve this question, this for whole thing, and you can get the CH bond formation energy. Now moving on to the next question. So this is for question number 42, whose answer is A. Question number 43. Question number 43 says that what will be the enthalpy change for the combustion of cyclopropane at 298 Kelvin? The enthalpies of formation of CO2, H2O and propane are given as minus 393.5, minus 285.5 and minus and 20.42 kilojoule per mole. The enthalpy of isomerization of cyclopropane to cyclopropane is minus 33.0 kilojoule per mole. Your options are A, 84.64 kilojoule, 8,844.63 kilojoule, B, 800 minus 844.63 kilojoule, C, kilojoule, D, 1893.44 kilojoule per mole. Okay, so all are given kilojoule. Sorry, not in kilojoule per mole. It's already given in kilojoule. So you have to find the enthalpy of isomerization of cyclopropane to propene. Okay, so how we'll do it? So first of all, write the equation here. Okay, once you are writing the equation and use these three, which is formation of CO2, H2O, and propane, to find the say the enthalpy of isomerization of cyclopropane to cyclopropene. So time to solve this question starts now. So your time is up. Moving on to the solution part. I've already explained the question to you. For those who have solved, the correct answer is C. So this is the isomerization process. Okay. And this value is given as minus 33.0 kilojoule. Next is your formation of CO2, which is also given as minus 393.5 kilojoule. So these things are given. And the formation of water is also given, which is minus 285.8 kilojoule. Right, so this formation is given and this formation is given and the propene formation is also given. So propene formation is given as 20.42 kilojoule and you have to find the change for combustion of cyclopropane. So this thing was also given, no problem. Now this is your compound. Okay, this is your cyclopropane. It is formed in this way, and for this is given as delta H is equals to 53.42 kilojoule. Now if you just do simple arithmetic calculation accordingly and systematically, then you will get your required equation, which is your combustion of cyclopropane. Now doing the same thing with the enthalpy change will give you minus 2091.32 kilojoule as your correct answer. So this is your correct answer. Next question. If the bond dissociation energy of xy, x2 and y2 are in ratio this and this, delta H formation of xy is minus 200 kilojoule per mole. The bond dissociation energy of x2 is what? The options are A 400 kilojoule per mole, B 300 kilojoule per mole, C 200 kilojoule per mole, and D none of this. So for the formation of xy, this thing is given, and that will be formed from x2 and y2, and the ratio is given for the formation. So how we'll solve it? Let us see. Before that, you have 10 seconds to solve this question. Your time starts now. So your time is up. Let us move to the solution. So three things were given: the bond dissociation energy of xy, okay, x2 and y2, and the ratio is given, which is 1:1:0.5. 0.5. Now the formation energy is also given, which is minus 200 kilojoule per mole for xy, and we have to find it for x2. For those that solved, the correct answer is D. So this is our equation, right? Very easy to write. Now putting all these values, we will get this x minus x as A. Clear? And x minus y is what? X minus y is also A. Therefore, bond dissociation energy of yy will be A by 2. Clear? Next thing is the formation of xy is given as 200 kilojoule. Therefore, we can use these three things, which is A by 2, and A. So why we are writing these three? Because the ratio is given in this way. So we are writing this thing. Now putting all the values, we have this one, this one, this one, and this one. We get the value of A, which is 800 kilojoule. So your correct bond dissociation energy of X2 is 800 kilojoule per mole. Moving on to the next question. Question number 25. 1 liter sample of mixing, 1 liter sample of mixture of CH4 and O2 produced at 25 degrees Celsius, and 740 torr was allowed to react at constant pressure in a calorimeter together with its contents, a heat capacity of 1260 kilocalorie. The complete combustion of CH4 to CO2 and water caused by temperature rise in calorimeter of 0.667 Kelvin will be the mole percentage of CH4 in the original mixture. The heat of combustion is given as minus 215 kilocalorie per mole. Your options are A 25%, B 15%, C 40%, and D 10%. So your 10 seconds to solve this question starts now. So time is up. Let us see how can we solve it. For those who have solved, the correct answer is D. So heat generated will be given by C into delta T. Very simple, because C is equals to Q by delta T. Now moles of molar mass of CH4 is also given, which is 16 gram per mole. Right. Therefore, energy of combustion of 1 gram will be how much? So it will be 2,15,000 calorie per mole, because I multiplied this thing by 1000. So thus enthalpy is equals to minus 840.42 calories. Okay, so we put this thing here, which is 16 by 215,000 multiplied by 840.2. We'll get this as 0.0625. Now the number of moles of CH4 is how much? So if this much energy is released and each has a molar mass of 16, therefore this thing by 16 will give you 3.91 into 10 to the power minus 3 mole. Moving further, we know that PV equals to nRT. If you put this thing here, PV equal to nRT, so that will give you N is equals to 3.92 into 10 to the power minus 12 mole as your correct answer. Now it is the mole percentage, so it will be 3.91 by 3.92 into 100. This is equals to 9.97 into is approximately 10% is your correct answer. So with this we have completed this question. Thank you.